Good evening to everyone from me also. I'm Christos, as Tina said. I'm a postdoc researcher in KU Leuven in asset studies, but also affiliated with Janssen the last 2 years, almost. And I would like also to give you a brief introduction how federated learning has been used in different applications and what can be the role of supercomputing in this new framework of federated learning. So this was the main article of NVIDIA for almost 5 or 6 months. So if you could log in the webpage of NVIDIA, you could see this article saying that medical AI needs federated learning. So when NVIDIA, the main provider of GPUs, her name is connected to machine learning, has this main article, you can understand that the need of federated learning is quite high in medical AI. But why do we need federated learning? One of the main reasons, as also said it before by Tina, but also by Lisbeth, is the fact that the data are fragmented. Different hospitals own data that cannot be stored in the same infrastructure. Furthermore, we cannot move the data. It's really labor-intensive and many times even not allowed to share data between hospitals to move the data. So we have the GDPR in Europe. Now in the States, they have also started increasing the privacy rules. So it's really difficult to move medical data. Furthermore, a model that is being built by Lisbeth, for example, for multiple sclerosis, might not be able to be used in Germany. There are different type of data, of course, but also the algorithms that the groups there are using are different. So AI models are generally not interoperable. And of course, there are different changes that might influence how fast we need the data. I guess that during COVID, you can understand that it was not easy to share data among different hospitals in Europe. So we needed to access the data remotely. And furthermore, in hospitals, the computational power that we have is not adequate. So federated learning suggests the combination of small processors all around Europe or all around the country in order to create a supercomputer. So different projects like Folding Home, for example, managed with the combination of more than 100 processors to create the first supercomputer to reach both 1 and 10 petaflops as a computational power. But of course, in a meeting for supercomputer, I'm not here to tell you that federated learning should replace supercomputers. Unfortunately, despite the fact that we have many successful applications in federated machine learning, the most famous of which is the first one about predicting COVID, but also for precision medicine, phenotyping, and I hope that Athena project soon will have some very interesting results. Unfortunately, federated learning have lots of challenges. The communication between the different nodes is very expensive. The communication via the internet cannot achieve the speed that we achieve when we are using a supercomputer. We have hardware heterogeneity between the different hospitals and the different processors that are being used. And although that it retains the model to the same silo, we have some privacy issues. And now there are being suggested even more computationally expensive models like multi-party computation that would not share the model, but you share just intermediate results. So the computation between the different modes is even more expensive. So federated learning is very good, but it seems that for the future is not the solution. But is it supercomputers that is the solution? I think that even this is not our solution. Maybe some of you know the Moore law that says that the computational power of every computer is duplicated every 2 years. And this law was valid almost until 2010. From 2010 and on, our computational power exponentially increases. We have a doubling time now of 3.4 months. So we cannot create supercomputers so powerful that can serve the computational power needed by machine learning applications. So to give you an example, from 2012, the most powerful supercomputer has increased its power for 200 times, while the most expensive computational machine learning problem has increased the complexity by 20 million times. So you can see we cannot live up increasing the power of our supercomputers. So what's the solution if it's not federated, if it's not supercomputers? Federated HPC. European Union and organizations around the world are trying to create a hybrid between federated approaches with small users and federated hypercomputer. I'm not an expert in hardware, but that's the idea of how it will be implemented. And there are different projects that have been initiated the last year, even less, the biggest of which is Gaia X. As you can see here in the center, the HPC, the hypercomputer performing facilities around Europe are envisioned to be combined all together, to be collaborative. And of course, there are a lot of challenges in the federated HPC. It's a very new topic. How the supercomputers will communicate is very challenging and not solved in the optimal way. But Gaia X says that in the end of the second half, so July, they will be able to start their federated HPC services. And there is also Phoenix infrastructure, which is collaboration between 6 different countries in Europe, Spain, France, Germany, that they also started trying to federate their supercomputers. So the Flemish supercomputer has already the opportunity, I believe, it has the opportunity to be the first Tier 1 federated HPC center. So we have in Belgium different hypercomputers that lie in the different universities, and it might be a very nice opportunity to try to create some projects that will try to explore the potential of federated HPC, which seems to be the future in the highly intensive and complex machine learning problems that we have. So, thank you very much.